We have this story where you put $3,000 into two different bank accounts, and I told you yesterday that nobody really calculates interest at the end of the year because the money is fluctuating daily through that bank. So instead of just waiting till the end of the year and then paying interest on what's in there, the banks pay interest at the end of every day. But that's a little bit more complicated to calculate. How do you pay 1 day's worth of interest when the interest rate is listed in a year? And we can do that using multiple compounds. So on the left side here, we're going to do a single compound per year, which is what you're used to. And the interest rate is 9%. How do we increase by 9% through a one-step multiplication? Times it by 1.09. So that's going to be our multiplier, 1.09. And we start with 3,000. And it's really easy to compute. We just multiply by 1.09, not 30. So 3,000. And then we times it by 1.09. And then we just keep hitting enter, which is kind of nice. So 3270, 3564, 3, and 3885.09. Oh, one more. Yeah, the bank's going to round to the nearest cent, but if they're paying you, they'll round up if necessary. If they're not paying you, or sorry, if they're paying you, they're going to just cut it off, round down. So this 0.087 is just going to be 0.08, and you lose 7/10 of a cent. But if there's interest, then they'll round up if it's higher than 5. Banks have lots of little tricks to have themselves make money. In fact, I read an article, I think it was in college when I read it, and I think it was in one of my classes. There was a lady, when banking first went electronic, there was a lady who wrote a program to take all of those partial pennies and funnel them into her own bank account. So in this case, 0.087, there's 7/10 of a cent that's flying out in space, and the bank just gets rid of it, rounds it off, and doesn't worry about it. And she funneled all of that into her own bank account. And after several years, she had made millions and millions of dollars, and then she went to jail. So not a good idea. And they actually, if you're a banker, if you work in a bank, you are required to take 1 week off, a whole week every year, because they found out that people were cooking the books every day. There were some sort of financial check in place, and so they were moving money around in certain accounts, and then at the end of the day, they would move it into their own account and spend it, but nobody could tell because all the numbers added up. So they make you take a week off so that you can't do that. And then while you're gone on that mandatory 1 week off, they make sure that nothing is fishy. So anyway, if you become a banker, you have to take a whole week off sometime during every year. All right, so 4234.74. Okay, that's pretty easy. It's the other side that's going to give us a little bit of trouble. We start with $3,000, and now I'm going to pay interest at the end of 6 months. So the question is, how much interest should we pay at the end of 6 months? Half of the yearly interest. And you can look at it two ways. You can look at it as half of the percentage, or you can look at it as half of the year. And in either case, you're going to take 9% and times it by 0.5. Right? Whether you're looking at half the interest or half the year, it doesn't make a difference. It's the same calculation. So what should I times 3,000 by here? What's the multiplier? 1.045. So 3,000 times 1.045. And that gives me 3135. Now what? I just keep doing that because every 6 months that interest is going to be paid. So you're not really paid 9%. You're paid half of 9% twice per year. So I multiply that by 1.045 and I get 3276. I'm not even going to worry about the cents till the end. 3423, 3577, 3738, 3906, and 4082, and 4266.30. What do you notice? It's a little bit bigger. Okay. So the first question underneath says, why does the second account grow faster than the first? And how come paying the interest more often changes the value? It's the same interest rate, still 9%. And so they're both considered compound, and simple interest, you'll hear the word simple interest. Simple interest means you get paid $6 every year. It's linear. So you start with $3,000. At the end of the first year, you get paid $6. At the end of the next year, you get paid $6. And nobody does interest that way, except maybe your parents, right? If they're paying you. All interest is compounded, meaning interest earns interest. But in this case, at the end of half a year, we have $135 in the bank account that wasn't there before. And that $135 is going to earn interest. Not very much interest, but it's going to earn a little bit of interest. Okay, and you'll notice at the end of 1 year, we're $6 higher with the semi-annual compound than we were before. So this piece right here earns $6 in interest in the second half of that first year. Okay? And now that $6 that's in this row is going to earn a little bit of interest in that first half of the second year. And you can see where that value is, and then that interest earns a little bit more interest. And at the end of year 2, we are what is that? So we are 577. We've gained what? $14? Oh no, the other line. We're actually almost $200 higher. And then that earned interest is going to earn a little bit of interest. And in the end, we ended up with about $32. Yay. So compounding twice per year will earn you $32 more than you would have earned if you just got paid at the end of the year. And banks are a little bit tricky. They usually don't pay you interest immediately. Right? At the end of the day, they calculate the interest. What do they do with that interest? They hide it from you, and they don't tell you what it is, and they don't put it in your account. So that interest doesn't earn interest. And then at the end of the month, or usually the end of the quarter, or sometimes the end of the year, they'll put all the interest in at the same time, which is a little tricky because then your interest doesn't earn interest. But you still, because you're getting paid more often, you're still going to end up with more. Oh yeah. Oh yeah. You could calculate it, but I've never had a bank account where they had a separate fund that told you how much you were going to make. It probably, yeah, I bet they would. Although interest rates right now are so terrible that you don't want to know. If you're getting 1/10 of 1%, it's really not worth it to find out. Okay. What would both accounts be at the end of 30 years? Well, the first one's easy. How do we calculate the first one? We use our equation 3,000 times 1.09 raised to the 30th. So the first account has 39,803. Okay. How are we going to calculate the second one? Because I don't want to hit enter a whole bunch of times on my calculator. Good. How many 4.5% interest will happen in 30 years? 60 of them. So we're going to take our 3,000 and we multiply that by 1.045. And because that happens twice a year, we have to double the number of interests calculated, and I raise it to the 60th. And you'll see it makes a huge difference. So that's, what, $1,200? A $1,200 difference just by compounding twice a year instead of once a year. Yes? So every year gets 2 compounds, right? And each compound is worth half of 9%. So we took 9 and divided it by 2, and that gave us 4.5, which is where the 1.045 happened. But now, every year we have 2 compounds instead of 1. So over the course of 30 years, you will have 60 compounds. And that's a great question because that leads us to the equation. How much would there be after 30 years if the interest was paid every month or every week? Well, we need an equation. How are we going to calculate monthly compounds? What are we going to do with 12? Oh, I heard 2 different things. What'd you say? No. No. So, what do we need at times by 30? We have to take 12 times 30. What does that tell us? That's how many months are in 30 years, and that's the number of compounds that will occur in 30 years. So that's 360. But we have to do something else, too. How much interest will we pay each month? 1/12 of 9%. So we have to do 2 different things. First, we need to take, maybe, please don't die on me. That would be bad. Oh. Sorry, it crashed. I'll have to pull it up again. Okay. So the first thing we need to do is figure out how much interest is paid. Really? Huh. We need to figure out how much interest is paid each month. So we take 9% and we divide that by 12. So 9 divided by 12 is 0.75. So we are going to pay 0.75% interest every month. So I take 100% and I add it to 0.75, which is 100.75. Turn that into a decimal, 1.0075. And that doesn't look like much interest, but remember, every month you're going to have a little bit more interest, and that interest will earn interest. How many times will I multiply by 1.0075? 360 times. Once every month for 36 years. So I take 3,000 and I multiply it by 1.0075, and I raise that to the 360th, and I get 44,191, which is higher. Oh, I lost the other numbers. So 44,191, and the others were 39,803 and 42,082. So that's another $2,000 just from calculating the interest every month. That's pretty nice, right? Well, let's make an equation. So the equation we're used to, and you're going to write it right here. The equation you're used to is y equals b times m to the x. And this is a single yearly compound equation. It's just the basic exponential equation. We want what is called the compound interest formula, and it's y equals, and instead of b, they use a capital P for principal, how much you put in. And they say you take 100% and you add it to what? The rate divided by the number of compounds. So we write R over, R is the interest rate, and if it's positive, you're going up. If it's negative, you're going down. And then N is the number of compounds per year. So in the last problem, it was 12. And then you raise that by N, the number of compounds times T. And T is X in what you're used to. But you'll always see the compound interest formula written this way. And it makes a lot of sense. All you do is add the rate divided by the number of compounds, so the interest paid for each compounded period, and then you raise it to the number of months, or sorry, the number of years times whatever value you are changing it by. So, yes? So the weekly? So, sorry, which one? Well, so monthly is a different account. This is yearly. This is semi-annually. And then this is monthly. So they're all different, right? This is just this with 12 compounds a year. If we did weekly, how many weeks are in a year? 52. So if I wanted to do this, I could say 3,000 times 1 plus, my interest rate is 0.09 divided by 52, and then I can raise that to the 52 times 30. And then you don't have to do all that thinking about, okay, the interest rate divided by whatever. You just plug it into the formula. And when we hit enter, I'm going to expect a number bigger than this. Okay, so when I push enter, ooh, it got bigger, but it didn't get very much bigger. That's going to be important probably tomorrow when we get there. Okay? Okay. So on the bottom of this worksheet, you are going to calculate some values, and I want to point out some terms. It didn't work. So number 1 says annually. What does annually mean? 1 compound a year. You can use the new formula if you want, where n is 1, but r divided by 1 is r and t times 1 is t, so that doesn't really help. So if it's annually, you can use the old formula. 45 times 1.08 to the 6th. So 45 divided times 1.08 to the 6th. 71, 40, 41. Okay. And then what about number 6 where it says quarterly? How many compounds? It would be 4. That would be compounding every 3 months. So we would do 100 times 1 plus 0.19 over 4 raised to the 4 times 8.5. So it's 100 times 1 plus the interest rate, which is 19.19, divided by 4, because that's quarterly, 4 compounds a year. And then we have to take our 8.5 years and times it by 4, because that's the number of total compounds in 8.5 years. So 100 times 1 plus 0.19, divide that by 4, and then I have to take my 8.5 years. That should be an exponent. So I raise that to the 8.5 times 4. Now, if you have one of the older calculators, you need to put parentheses around the exponents. So if your calculator looks like this, if your calculator does that, you have to put parentheses around that. Otherwise, you'll raise it to the 8.5 and then you'll multiply the answer by 4. If you have one of the newer calculators where you land up here in the superscript, then you don't need parentheses. So sorry, Tiana. That's what you get for living in the past. Okay. What is daily interest going to be? What's your n value? How many compounds will there be in 1 year if you calculate it every day? 365, except on leap years, it'll be 366. Okay. And then number 12, how are you going to do hourly? How many hours are in a year? It's going to be 24 times 365. Okay. What if it said semi-annually? Every 6 months, so n would be 2. And then number 8 says 2 months. So if you compound the interest every 2 months, how many compounds will there be? 6 per year. Okay. So you need to do 1 through 12 on this page. And then you also need to work on the compound interest paper. And then if we have time at the end of class, we'll get into the continuous interest one, which is kind of interesting. Okay, get to work.